Hey guys, welcome. We're going to go ahead and go through the first open response question for your second practice exam in organic. All right, so we're going ahead and move on to the first open response question here. So that's going to identify if each of the rings are either aromatic, non-aromatic, or anti-aromatic. I really enjoyed these types of questions when I was in organic just because I was able to use a really kind of easy process of elimination, at least easy in my mind, that always helped me get to a final answer pretty quick. So something to really remember about the non-aromatic molecules is that they can have an sp3 hybridized carbon. So what that means, if you can't remember back what sp3 means, it just means that it's going to be that alkane. Okay, no double bonded atoms attached to that carbon. So in the first one here, yes, while this molecule does appear to be cyclic, the first thing that I actually notice is this right here, this sp3 hybridized carbon. And to prove it to you, I'll show you. It is single bonded to this carbon here, single bonded to this carbon here, single bonded to a hydrogen, and single bonded to another hydrogen. So we would know that this molecule is then non-aromatic. Okay, the next one's a little bit harder, but I'm hoping that I can reorient your thinking and make this make a little bit of sense to you. So I'll take a different approach because I don't initially see an sp3 hybridized carbon, and that's always a really telltale sign of non-aromatic. But we can go through and count our double bonds and see that there's 1, 2, and then we'll draw in our electrons on this sulfur atom. And because there's only one pair of electrons in this p orbital on the sulfur atom, and these electrons can move in resonance, we only really look at or count just one set of those electrons. So there's 3, and that means that there are going to be 6 pi electrons. And here we would use Huckel's rule to see if that works for us. So we can say then we have 4n plus 2 is going to be equal to 6 pi electrons. We'll subtract our 2 from both sides to get 4n is equal to 4. And n is equal to 1. And does that satisfy Huckel's rule? Yes, it does. It's exciting, right? We know that this molecule is then going to be aromatic. Okay? On to the next one. Hopefully this one is not as difficult as this guy here, but let's just go through and we'll count our double bonds and see if we're going to satisfy Huckel's rule again. We see 1 and 2 and 3 and 4 and 5, and on your own, do you guys notice any sp3 hybridized carbons? Because I'm not seeing any. So that means is that we would have 10 pi electrons. And does that satisfy Huckel's rule? Let's go on ahead and look. n plus 2 is equal to 10. Subtract our 2 from both sides. We would get 4n is equal to 8. And n is equal to 2. So yes, that does satisfy Huckel's rule, and we can thus justify that this molecule is aromatic. All right, I hope that makes sense. Thank you guys so much for watching.